So in the last few sessions, we have talked to you about relations, and in this one onward, we are going to talk to you about functions. So let's get started with the most basic definition and value of a function. This is the part one of this concept. So we are mostly going to talk about definition. So already you are familiar with relations. So let's get started with a basic arrow diagram. If you look at the element A, it is associated with two elements of B. Similarly, the same thing holds for C as well. So definitely they have two images under this relation. In fact, if you look at this arrow diagram, C has no image at all. So previously we said that relation is a rule that associates each element of A with elements of B, but for a function you have different restrictions. It has to associate each and every element of A with a unique element of B. So this is very important that you understand this particular criteria. Now, basically what we are going to do is take a function from A to B. It is actually mapping X to Y. We can say that Y is the image of the element X under the function of the mapping. We alternatively write Y equals to Fx. Now, there are two things which we are actually concerned with when it comes to relations for functions. So we need the existence and the uniqueness. So let's see some examples of arrow diagrams so that you have a clear idea whether a relation is a function or not. Look at the first one. Each and every element of the first set is uniquely related to elements of the second set. So this is all right. For the next one, C has no image at all. So definitely it's not a function. For this one, this is perfectly all right. Whereas for this one, you have A having two images. So even if there's violation in uniqueness or existence, it's not a function. Now, apart from the arrow diagrams, it's also necessary that you understand some basic definition and different examples regarding that. So you know that it's not always possible for us to write the relations or the functions in the roster form, in general set in roster form. So let's talk about some general examples. So y is 3x plus 2. So y is basically the output. It is 3 into the input plus 2. Now, if you take any real input, you will get a particular output for it. So definitely it is a function. You give any value of x, which is a real number, you definitely get a value, and it's a unique value. So this is all right. Now let's take another example here. So what we are going to do is we are going to take any x in R and see whether you have a unique element which is it is mapped to or not. So definitely if you consider any x in R, you will see that for some of the cases you can have more than one value. For example, I'm considering x equals to 2. Now y has to be less than 5. So if I take y equals to 1 or y equals to 2, that will definitely satisfy this equation. So there is something wrong with the uniqueness of image. So this is not a function. So at the end of this video, I hope you understand what we mean by a function and how it is special when it comes to a relation, what are the things it needs. In the next one, I'm going to talk to you about the different types of things a function has to possess so that it's not exactly a relation, but a special type of relation, and also the value of a function. So stay tuned.